Good morning, good afternoon. Hey, everybody. Welcome to the August monthly demo. We are going to give it just another minute or two, and then we will get started. Okay, I think we have gotten to a quorum with folks filtering in. Once again, good morning, good afternoon, good evening. Welcome to our August monthly demo. My name is Andy Gower, even though below it says Michael Ferranti. I am not Michael Ferranti, I'm Andy Gower. I'm a solutions marketing manager here at Portworx, and I'm thrilled to be joined today by Bob and Shah, who's going to help take us through this deep dive on Tanzu and what we're doing with Portworx here on Tanzu. Quick roadmap for today, for those of you who have joined us before, we're going to spend about 10 minutes up front talking about Portworx and the broader platform, what we do, kind of why Portworx is so critical to that last mile as you move into your Kubernetes stateful applications and bringing mission critical workloads onto Kubernetes. And then I'm going to turn it over to Bob for the rest of the time to talk about what we're doing with Tanzu and to show a demo of what we're doing in earnest. So with that, let me go ahead and jump in. You know, the place I always like to start is data. I think it's evident as we have gone through the world in the past 2 years that data is really the thing that is powering businesses. It's that new oil that's giving businesses the ability to derive insight, to derive value, to bring out new products and services that really speak to their customers. And what we're finding is as we've moved from this analog world to this digital world, we've seen winners and losers. And the winners are those who are embracing this digital business. They're embracing this move to faster insights, to faster value, to processing the data more quickly. And they're doing that with a new cloud native stack. They're doing that with a stack that is built on a multi-cloud infrastructure that's driven by automation from Kubernetes and containers. And it uses a wide variety of mostly open source data services and databases to help deliver value throughout the application. And it's given rise to a new set of tools and processes, things like DevOps and GitOps, the rise of the SRE, other things that are fundamentally changing the way enterprises are thinking about their business. But they're doing it ultimately to derive value from that data and be a winner in this new digital-driven economy. Now, of course, containers and Kubernetes are the driving force of this. We're seeing 95% of new apps are being developed in containers, according to 451. 78% of CNCF members are using Kubernetes in production. We've got 81% of enterprises are working with 2 or more public cloud providers, and 85% of global businesses say they'll be running containers in production by 2025, up from just 35% in 2019. So containers and Kubernetes are leading the way in this new cloud native stack. They're really driving the new innovation in this stack. But, and there's always a but, Kubernetes and containers don't talk storage on their own. So as great as container platforms are, as great as those container platforms we see and talk about and hear every day are, they don't provide the automated, scalable, turnkey storage and data services that you need to have true production grade deployments of this new cloud native stack, of these new cloud native applications. Because really, once you move to this new stack, you still have to think about the data. You still have to think about, how do I make sure that data can move easily between clouds? How do I make sure I'm protecting the sensitive user data that's within my application? How do I make sure I'm delivering performance within the strict SLAs, the same SLAs I had in my traditional environment, now in my new cloud native environment? How do I make sure I have DR, backup, recovery? All these things that are critical business requirements in the traditional world are now here to stay in the Kubernetes world. But when we look at the traditional storage services. They're fragmented. They weren't built for containers. They weren't built for Kubernetes. They were built for a traditional machine-based world where maybe you were doing 10 to 12 actions a day. Maybe you're scaling to hundreds of volumes, not the hundreds of thousands of volumes that containers have. Maybe you're putting the data somewhere once and never moving it, whereas in containers, with containers and Kubernetes, you're moving it all the time. So you need to think about this stack in a new way, and what are the storage services and the data services I can provide to make sure I'm supporting my app that's built from the start on Kubernetes, that's built from the start to live in containers. And in the short version, that's what Portworx does, right? We deliver a modern data experience that the cloud native apps require in order to scale and in order to be highly available and in order to go into production at scale in this new cloud native world. Now, if you're just learning about us, we are the leader in this space. We've been recognized by GigaOM in 2 categories that just came out in the last month or 2. So on the left, we're the leader in cloud native data storage. And on the right, we're the leader in enterprise Kubernetes storage, along with the bigger Pure brand. And we're also a leader in Kubernetes data protection, which is not pictured on this slide. Now, our customers are some of the largest and most sophisticated customers in the world. And the reason I show this slide is to say, if you have a challenge with containers and Kubernetes, we've likely solved it already for another customer. And we can take that insight and we can take that expertise and apply it to you as you're going along your container journey. We can bring that to what you're doing in your enterprise. You see on the right, we also have a wide net of partners. So we work across the board with Kubernetes distributors, with the partners. Today, of course, we're focused on Tanzu. But really, wherever you are in your container journey, we're able to support you, and we have expertise in supporting that Kubernetes distribution. Speaking of Kubernetes distribution, at the heart of it, Portworx is the leading Kubernetes services platform for building, automating, protecting, and securing cloud-native applications. And we work on any Kubernetes distribution, including Tanzu, that we're going to speak about today, on top of any cloud, using any infrastructure, whether it's Pure infrastructure, IBM infrastructure, bare metal, Dell, NetApp, VMware, whatever the infrastructure, we can support it with any app and at every stage of your journey. So from the time that you conceptualize the new application on a whiteboard, to the time you move to dev test, to the time you go live, to the time you scale it globally, Portworx is able to support that entire life cycle across any of these distributions, as I mentioned. Now, Portworx itself is composed of 6 key modules, and Bobin's going to go into these in a little more detail as they relate to Tanzu specifically, but 6 core modules starting with Pxstore. So Pxstore is our software-defined storage layer. It automates container storage for developers and administrators, and it makes it easy for you to deploy your Kubernetes applications at scale. Pxmigrate is really focused on how do I move applications between clusters or between clouds or between data centers? How do I make sure that I have availability across the board in that scenario? Pxmigrate helps us do that, helps us leverage multiple clouds, helps us leverage a hybrid cloud setup and do that seamlessly with a single click. Pxsecure, of course, security, ransomware, all top of mind across the industry today. And Pxsecure is really focused on ensuring that we have consistent encryption and security policies at the container level, at the application level, at the namespace level. We use things like RBAC and BYOK to make sure that we are lowering the risk and automating the protection for your container environment. PXDR is focused on ensuring high availability replication, both synchronous and asynchronous between availability zones and regions in cloud. We're able to eliminate downtime with 0 RPO within a metro area. And we also provide continuous backups across a wide area network for greater coverage. And this is one that I think Bobin's going to talk in a little more detail today. PX Autopilot, we also are able to help you ensure that your costs are managed as you move to a underlying cloud. So with PX Autopilot, instead of having to buy, say, 100 terabytes up front, we can help you auto scale as your app grows to reduce costs. So you can say buy the 40 terabytes you need on day 1. You can put some automated rules in place that say, hey, if I get to 35 terabytes, add an additional 10 and scale accordingly. And by doing that, we can help you save up to 65% on your underlying storage costs, your cloud storage costs. And last but not least is PX Backup. PX Backup is available both as part of the PX Enterprise platform and also as a standalone. PX Backup is architected from the ground up to provide complete app consistent and container granular backup and recovery of Kubernetes applications. It was built to speak the language of Kubernetes. We're able to provide app awareness. We're able to provide container granularity. We're able to make it simple and easy for you to make sure that your application is backed up and restored to maintain governance and to maintain compliance. So the last thing I want to touch on before I turn it over to Bob, and I want to quickly run through 4 stories of success we've had with Portworx and our customers. The first one is T-Mobile. T-Mobile was all about speed. So T-Mobile faces a couple of challenges. One big one for them is whenever a company like Apple or Samsung comes out with a new phone, there is a huge surge in traffic on their website, a huge surge in demand for their product, a huge surge in need for new applications or new marketing campaigns to address the new iPhone or to address the new Samsung. Well, T-Mobile was struggling with both that surge in demand to their website and also their app deployment times. It was taking them 6 months to deploy new apps. By moving to Portworx under the covers, they're able to reduce that app deployment time from 6 months down to just hours, while ensuring that they have the backend to scale with that surge in demand. So they can move faster. There could be a new application out the same day as an Apple announcement, and that speed was critical to their business success. The next is Roblox, and this one's really focused on agility. So Roblox in March 2020 scaled as much in 1 week at the beginning of the pandemic as they'd scaled the entire previous year. So that's a generational shift. That's a complete fundamental change in demand for your product. And you have to have the agility in place to handle that surge and make sure that 70 million gamers don't go offline and have problems. So with Portworx on the back end, we're able to give them the flexibility and the agility they needed to scale to support that increase in demand and be able to make sure those 70 million gamers stayed happy on the platform and continue using it today. The next one is reliability with RBC. So RBC moving down a container journey using Kubernetes, and they've moved some apps, but there was a critical banking app that they wanted to move into production on Kubernetes. But there is a big business requirement that said this has to have 0 RPO. We have to be able to withstand a complete data center failure with 0 data loss. Well, with Portworx and our PXDR capabilities, we were able to provide that so that they could have 0 RPO and a fast RTO across 2 completely independent data centers and have the confidence and the reliability they needed to put that banking app into production on Kubernetes and gain the benefits of Kubernetes along the way. And last but not least is Audi Business Innovation. So Audi Business Innovation didn't come into their container journey looking to save money. They came in looking for speed and agility and reliability. But with PX Autopilot and the ability to auto scale their cloud storage on the back end of their Kubernetes deployments, they were able to cut their bill with AWS by 60%. So they gained the speed, the agility, and the reliability they needed, but they also saved a bunch of money in the process. So it was a real win-win across the board for them. So these are just 4 examples. I'm not going to go into any more today. I'm going to make sure Bhavin has plenty of time here to talk about Tanzu. One last thing I want to call out before I turn it over to Bhavin. 3 ways you can get started with us. We've got a Portworx Essentials Forever Free option. We've got a Portworx Enterprise free 30-day trial. We've got a PX Backup free 30-day trial. And you can find all those at portworx.com/free trial. So please, at the end of this, if you're interested, if you want to find out more, hopefully we've piqued your interest, please check out those free trials. And also next month, we're going to have a great topic. It's going to be PX Secure and OpenShift is going to be our monthly demo next month. So please don't forget to sign up for next month's demo at the end of today's session and join us for that discussion. So with that, Bhavin, let's talk about Portworx and Tanzu.
Awesome. Thanks, Andy. Good morning and good afternoon, everyone. So again, the focus for this presentation is VMware Tanzu. But then what do we mean by VMware Tanzu? So when it comes to Portworx and running your stateful applications, we think about VMware Tanzu in terms of the underlying infrastructure. So you can have VMware Tanzu that's running on a VMware Cloud Foundation stack. So vSphere for compute, storage, and then NSXT for the networking layer. And you can have Portworx running on that. You can also run it on vSphere with Tanzu, which is just, if you don't want to go ahead with the full-fledged NSXT stack, you can use the virtual distributed switch plus HA proxy, or you can use the new NSX advanced load balancer from VMware as the two different networking options, and just use your basic vSphere cluster to run VMware Tanzu and then run Portworx and your stateful applications on top. Or if you're just using the open source distribution from VMware, which is their Tanzu Kubernetes Grid or TKG, you can still run Portworx on it. So regardless of what your infrastructure looks like when it comes to VMware, you can run Portworx on VMware Tanzu to help provide persistent storage for your stateful applications. From a use case perspective in this presentation, we'll try to cover multiple different use cases around data protection and disaster recovery. But just to highlight something that Andy already spoke about, like when it comes to Portworx, we have all those different 6 modules with pxsecure, autopilot, store, DR, backup, and I think I'm missing one, but you can use all of those with VMware Tanzu. But what benefits does that give you? So just by using Pxstore and Px autopilot, we allow you to run or easily deploy Portworx on your VMware Tanzu clusters, and without any additional pre-configuration needed from you from a storage perspective. So you don't have to go ahead and configure your VMFS data stores, or you need to provision those VMDKs separately outside Tanzu or outside the Portworx deployment process. We have automated the whole process for you. So in the first piece of the demo that we do today, I'll quickly show you how easy it is to get started with Portworx on VMware Tanzu, and then we'll dive deeper into a couple of additional use cases. So one of the things that we'll talk about is around business continuity and disaster recovery. As you heard Andy talk about RBC, and one of their prime requirements being synchronous DR or an RPO of 0, we'll look at how you can use Portworx Sync DR or Metro DR for VMware Tanzu and achieve that RPO of 0. We'll also talk about Async DR when it comes to VMware Tanzu and Portworx. So if you have clusters that are more than that are on different coasts, or the latency, you're not able to meet the 10 millisecond latency requirements for synchronous DR, you can still use Async DR with a certain RPO that is supportable by the throughput that you have between the two sites, and still build a resilient and robust architecture from a disaster recovery perspective. We'll also look at use cases like data protection. So we'll use a PX backup to protect applications that are running on VMware Tanzu, and then do a local restore today. But we have additional videos on YouTube where you can see that how we protect applications on-prem and restore them in the cloud if that's what you need. And then the last is automated capacity management. So this is where Px autopilot comes in. And we have done this demo previously, so where we show how Px autopilot can dynamically expand your persistent volumes or dynamically expand your underlying Portworx storage pool when your stateful applications need more storage. So instead of having to open tickets, or as you as an operator need to monitor the storage consumed by your Kubernetes clusters, Px autopilot reduces that overhead, does all of that for you by just specifying autopilot rules and triggering certain actions when specific conditions are met. So that's it for the slides piece of the demo. Let me share my screen and we'll jump into the demo. Okay, perfect. I figured out which screen it is. Okay, so if you looked at Andy's slide on how you can get started with it and start your free trials, you will eventually be navigated to central.portworx.com, and this is where you can generate configurations. So we'll spend like 2 minutes on looking at how easy it is to deploy Portworx on VMware Tanzu. So once you come to this page and you have logged in, you can generate a new spec. Here we'll use Portworx Enterprise or PX Enterprise. We'll click next. You can either choose to deploy it using our operator, or if you don't select that box, we'll use a daemon set deployment method. We can specify the version of Kubernetes that's running on your VMware Tanzu environment. For my lab, I'm running 1.19.7, so I have entered that. I'll select version 2.8. Again, if you're running a test dev cluster, you can go ahead with the built-in HCD. If you're running a larger production cluster, we recommend using an external HCD for our key value database. We'll go ahead with the built-in one because this is just a demo. We can select cloud, and that's where you'll find VMware Tanzu as the requirement. From a storage configuration perspective, we'll specify the storage class that you have in your VMware Tanzu environment, and basically Portworx will use this storage class to provision VMDKs for you and mount those VMDKs on TKG or Tanzu worker nodes. At the end, then like once all the VMDKs have been mounted and up and running, Portworx will aggregate them into a single storage pool, which can be consumed by your a stateful application. So again, this is it. Like I don't have to do any pre-configuration. I just need to know the name of the storage class that Portworx can use to provision those VMDKs. We'll click next. You can leave everything else as default. And again, if you want to make changes in terms of the ports that Portworx uses to talk to each other, like for individual Portworx nodes to communicate with each other, you can do that, or you can leave everything as default. We are not using Anthos or OpenShift. We are using VMware Tanzu, so we select none. You can specify additional environment variables if you want to like have additional things like, okay, which team is using the specific cluster. You can create new key value pairs here as well. If you're using a private registry, you can provide those details here. And then by default, we enable monitoring and telemetry and CSI for you. But if you want to disable anything, let's say I don't want Portworx to install a Prometheus operator and a Prometheus instance for me because I already have one running, you can deselect that box and then just click finish. Read through the EULA. So again, that's very important. We won't read through it today, or else we'll need an hour just for reading the EULA. But we'll agree to it, and then this is it. Like this single command, and again, you can look at the whole specification if you want to. But this is that one single command that you copy and run it against your Tanzu Kubernetes clusters, and Portworx will be provisioned for you. So this is how easy it is. You don't have to, like if you are an operator or if you are a VMware administrator, you haven't interacted with Kubernetes before, this is a simple user interface that you can use to generate a configuration for Portworx and then just apply against your VMware Tanzu Kubernetes clusters. So I can save the spec. Again, if I have multiple clusters and I want to make sure I have specs saved, I can do that as in my account, or I can just download the specification to store locally. But that's it for like the UI piece. Let's log into the lab and run through a few different scenarios. So right now I'm not logged into any of the Tanzu Kubernetes clusters. I'm just connected to a Linux VM that has access to it or can talk to all my Tanzu Kubernetes clusters that I've deployed for this demo. So let's start with the Async Dr demo. For Async Dr, what we have here is we have two identical VMware Tanzu Kubernetes clusters called Async Cluster A and Async Cluster B. Let's log into the first one and then change the context. So we point to the correct cluster. If you do a kubectl get nodes, you will see that it's a single master 3 worker node TKG cluster running on my VMware environment. I can do a kubectl get pods in the kube system namespace to see that all the Portworx pods are up and running. And again, I deployed this cluster this morning, so they have been running for the past close to 6 hours. I can look at additional things like I have namespaces that have been deployed for this demo. So we'll use the demo namespace today. Let's go ahead and deploy a simple application that we'll use for our DR testing. So let me go to the correct folder. Okay, and then apply that YAML file. So we'll deploy it in the demo namespace. What these YAML files are doing are deploying Kubernetes objects for me. So if I do a get all in the demo namespace, it deployed a couple of deployment objects that basically deployed replica sets and pods for me. A couple of service objects. If we look at persistent volumes in the demo namespace, we have a Postgres data persistent volume that's using the Portworx Postgres SC storage class, like it's of the size 10 gigs, and it's now attached to our Portworx pod that's running in the demo namespace. So now we have the application that's up and running. Let's go ahead and access the front end. And then this is a very simple app where basically wherever you click, it generates a Kubernetes logo and stores it in the Postgres database. So now that we have generated some data, let's go ahead and look at how you can create those DR relationships. So the very first thing that we have to do is we need a cluster pair between the two sites. So cluster pairs are specific to a namespace. So right now I don't have any. Let's do apply on the cluster pair file, and then we'll basically look at what the configuration looks like. So if I do a VI into it, cluster pair basically gives me the namespace that it will use. It gives me the destination cluster. So again, we were logged into the async cluster A. My location or my destination is async cluster B. I can specify additional things like the IP of the Portworx service on the second site, the port number, the cluster token, and the mode as disaster recovery. Once I have all of these things configured, I can apply it, and then I can just do a get cluster pair in the demo namespace and see that it's already running. If I want to find out more details about it, I can do a stalk.ctl get cluster pair in the demo namespace, and you will see that my relationship, my DR cluster pair between my site A and site B cluster is ready to go. The scheduler status is ready. The storage is linked as well. So as the next step, we need to define a schedule policy. So let's apply it first, and then again we look at what the file looks like. So demo schedule policy, and again this is as an administrator, you can control when your data and your Kubernetes objects are moved from your source site to your destination site, or your site A to site B. So we just gave it a name, pointed it to the same namespace. We have configured an RPO of 5 minutes for this demo. You can go as low as 1 minute if you have the throughput to support it. And then in addition to every 5 minutes, we have a daily, weekly, and a monthly schedule as well. Again, as an operator, you can configure these things and deploy a schedule policy that works with your predefined SLAs. So now that we have the schedule policy defined, we can do a kubectl get schedule policy. We see that our demo schedule policy is already created. Now let's go ahead and look at our migration schedule. So this migration schedule is the meat of our async DR relationship. So here we specify like what's the name of the cluster pair, the first thing that we deployed in this demo. Include resources, yes, because we don't want to just move our persistent volumes and data, but we also need all the different Kubernetes objects and the application configuration that's needed for my stateful app. Start applications is set to false because after each migration, I don't want my application to also come online on the second site. That will create application inconsistency. So since this is a disaster recovery operation, we'll keep the start applications to false. And once there is a failure event and I need to bring my applications online, that's when we'll scale the number of replicas in the deployment or activate our migration. And then you can associate which schedule policy you have to assign for this specific DR. So again, this is the same demo schedule policy that we just created. Let's exit out of this, and we can apply this a YAML file, demo migration schedule.yaml, and this basically creates a migration schedule object for me. I can use kubectl in the demo namespace to see if it's up and running. I can also use stalk.ctl in the same namespace to get a migration, to get more details around the migration schedule. Right now, it is actively running. It doesn't have anything because it hasn't completed one successful run. So there's nothing filled out in the last success time and last success duration. But suspend is false, which means that it's actively running. We can This is the migration schedule, but then for every 5-minute interval, or the interval that we have defined in the schedule policy, it will create a migration object. So we can do a kubectl get migrations in the demo namespace, and you will see that there has been a migration that kicked off 51 seconds back. I can do the same thing with startctl and look at the migration. So here you can see more details about it. So it's using the cluster pair that we just defined. Right now it's at a stage where it's copying over my persistent volumes from site A to site B. And in addition to volumes, once that's done, I have resources that will be copied over from site A to site B as well. So we'll get more details around this once the migration is completed. But I can also do kubectl describe migrations in the demo namespace to get more details, like, okay, what's happening, persistent volume migration is successfully done, services are migrated successfully, my deployment objects are migrated successfully. So if I go back and run the stockctl get migration command, you'll see that, okay, my stage is final, the migration was successful, one persistent volume which was part of our application was moved, and 7 different Kubernetes objects were moved to the second site. So at this point, whatever data we generated on the first site will already be present on the second site, but I can't access it yet because pods are not up and running. We don't want to create that inconsistent state. So let's go ahead and suspend the migration on the first site, or site A, and then we'll bring the application back online on the second site, and let's hope it works. So we can use the startctl suspend command, migration schedule, and then the name that we used was demo migration schedule, and we'll point it to the demo namespace. Demo, I think I have a typo there. Let me fix it. Let's verify that that's the correct name. Demo hyphen migration schedule. Okay, migration schedule demo hyphen. Okay, so it's suspended successfully. So if I run a startctl get migrations schedule command, it will show that suspend is true. So there's no, if I write any more data on the first site, it won't be copied over to the second site. And again, this is since we haven't like simulated an actual failure, or we haven't had an actual failure at site A, I have to do this to make sure that the replication stops and we are able to bring the applications online. But in case of an actual disaster event, you won't even be able to access your first site. So you can just follow along and use the following steps on your second site, and your application will come online. So let's log out of the site A cluster, and let me copy the big command that I have for site B. So this command basically logs into the second cluster, which is async -cluster-b. It's just using the Tanzu or vSphere plugin for kubectl to log in using our administrator at vSphere.local credentials. So once I hit enter, I need to provide it the password for my admin at vSphere.local account, and then change the context. Not demo, async cluster B. Okay, so here, if I do a get nodes, you will see that we are in the second cluster now. It's a similar cluster with 1 control plane and 3 worker nodes. It has Portworx running as well. The cluster pair relationship that we created on the first site is valid here as well. Let's do a get all on the demo namespace. This is where our pxdr is all like it already has all of our Kubernetes objects copied over. So you can see that the couple of service objects that were part of our application are already created here. Since it was configured as load balancer, it already got an IP for our load balancer instance. Deployment object has been created, but the replica count has been set to 0 because again, we didn't want applications to be online on both sides. So we can just run a simple command, startctl activate migrations, and then we can point it to the demo namespace. And that basically increases our replica count to whatever it was on the source side. So this is basically creating new pods for me on my second site, which means that if I try to access the service endpoint, I'll be able to hit the pod that's behind it and access my application on the secondary site. So if I do a kubectl get pods in the demo namespace, I'll see that I have a couple of pods that are already running because they were created. If I do a get pvc, I should have done this before we created pods, but again, you'll see that the same configuration exists on the second site as well, a persistent volume that's called Postgres data. Let's try to navigate to this new external load balancer IP. Again, if you are familiar with how VMware Tanzu works, this since we are using NSX Advanced Load Balancer, my stateful applications or any kind of application running on Tanzu can set the service type as load balancer, and my NSX Advanced Load Balancer instance or NSX ALB instance will provision a load balancer IP for me. So again, there's no pre-work required. I don't have to go and talk to my network admin. This is the agility that Kubernetes and VMware Tanzu brings from a compute and network perspective. So let's navigate to the new IP address, and as you can see, we have the same logos appear on the new site as well. This is just like, again, it's a simple application. It captured, it basically queried our Postgres database and identified the pixels where the logos existed and put pixels here. My source application will not be available because we failed it over, but this is an older instance and we have the new application that's already running. So this is how easy it is to have Async Dr. If you are in the VMware ecosystem, you might have used SRM. SRM does the similar thing for virtual machine-based applications, where you can specify your protection groups and your recovery plans for each application. And then if in case of a disaster, you can basically navigate to the SRM instance and activate those recovery plans, and your application is deployed for you on the second site. So Pxdr does that for your stateful applications that's running on VMware Tanzu. Hopefully that was a good demo. Now let's move on to the second demo, where we talk about Px backup. So we looked at Async Dr, we look at data protection using Px backup, and then finally we'll also look at Synchronous Dr with that RPO of 0. So for Px backup, let's navigate back to our CLI interface and log out of the async cluster B. I'm just trying to look up the login command that I've had ready. So again, we are logging into the same Tanzu endpoint, but just a different Tanzu Kubernetes cluster, Px backup cluster in this case, using the same admin at vSphere.local account. So after providing the password, I can change the context and then Px backup cluster. And if we do a get pods in the Px backup namespace, you will see all the different objects or pods that are responsible for my Px backup instance, and they're all of them are in the running state. I can do a kubectl get service as well in the Px backup namespace and get the endpoint for my Px backup UI. Again, this is using service type load balancer, so I got an IP address from my NSX interface. This is the user interface for Px backup. So we'll just log in using the credentials that I configured during Px backup deployment. Let me zoom in. So, oops, not this. Sorry about that. Okay, let's zoom in a bit so this is more readable. Here you can see we have a couple of clusters that are attached to our Px backup interface itself. In addition to the Px backup cluster, we also have a Px demo cluster that's attached. As like when you click on each cluster, you will get a list of all the different namespaces and applications that are already deployed on your cluster, and you can just select a specific namespace. It automatically selects all the resources if you want. If you want to narrow down the number of resources, you can do that as well, and then just hit backup, and you can create a new Kubernetes native backup for your stateful application. And again, we look at this workflow. One thing that I wanted to highlight was Px backup also gives you a single user interface that you can use to monitor how your backup jobs are running. So you can look at the past 24 hours. So again, if you are an operator, you can log into this UI every morning, make sure that you don't have any failed jobs through the night. Again, if you have any failed jobs, you'll have this icon that shows up on top of that bar chart, on top of that bar. You can go as back as 30 days to look at how your backups have been doing. Again, I had this environment running for the past 4 days. You see that I had some backups running on and off for all the different days. And again, all of this is configurable by the user, but this acts as a good user interface that you can use to monitor your backup operation. If you want to switch to a different cluster, you can just click here in the drop down, select the PX backup cluster, and you can create a new backup job. Before we create a new backup job and perform a restore operation, a couple of additional things. You can navigate to schedule policies, and this is where you can define your schedule policies for your backup operations. So in order to meet your SLAs, if you need to back up certain applications or just some persistent volumes every 15 minutes, you can do that. You can have a full backup at the end of every day. You can configure that as well. So it's as easy as just giving it a new name and then selecting the type. So periodic allows you to specify it in terms of hours and minutes. Daily is once every day, and then same goes for weekly and monthly as well. So this right now, if I for this demo policy, I'm specifying that every 1 hour 15 minutes, it will create a new backup job if I end up using this policy. So that's how easy it is as a backup admin or as a VMware admin to create backup schedule policies. And then you can use the same instance of PX backup to attach different cloud backends. So if I'm running PX backup on-prem, I can still use that same instance of PX backup to protect my applications that might be running in Amazon EKS or Azure or Google GKE clusters. I can do the same thing when it comes to my backup repositories. So right now for this demo, we have a pure FlashBlade system, which is acting as our S3 endpoint for our backup repository. But you can add Amazon S3, Azure Blob Storage, or Google Cloud Object Storage buckets as well as endpoints where you can store your backup jobs. So you can have flexibility in terms of, okay, I want to store local backups every hour, but then I also want to ship my backups in the cloud on a daily basis to make sure that I have a remote copy in case my on-prem, in case of like my on-prem backup repository being unavailable to restore from. So now we have all of that. We can go ahead and click the PX backup cluster. We have a simple WordPress site that's running on my PX backup cluster. And if we go back to the CLI interface, I can show you all the different resources that form that WordPress app. So we again have two different service instances, two deployments, which means two pods. And then if I do a kubectl get PVC for that WordPress namespace, you'll see that we have two persistent volumes. So again, that's what a Kubernetes stateful application means. Looks like it has all different kinds of objects that I need to protect as a whole to ensure that I can recover them perfectly when in case of an accidental deletion or data corruption or ransomware, as Andy mentioned earlier. So I can just select WordPress. I can select all resources, or if I don't want, I just want to create a backup job for my persistent volumes, I can select, if I can scroll perfectly, correctly, I can select my persistent volume claims and just back up my persistent volume claims. But I want to do everything for this demo. So I'll select all resources, click on backup, and then we'll create an on-demand backup. So we'll give it an appropriate name. We'll select the PX backup repo that was configured, and then we can select a schedule if we want to. So this is our hourly, daily, 4 hours, the demo policy, schedule policy that we just created. I can select that, or if I want something that's on demand, I can do that as well. If I'm using any of the distributed databases like Cassandra, I need application consistent snapshots. PX backup gives you the ability to create pre and post backup rules to ensure application consistent backups, not just crash consistent. So you can use that as well. And then I can additionally specify any backup labels that I might want to. I can hit create, and it basically kicks off a new backup operation. It talks to my Kubernetes API server for my PX backup cluster and protects all the different objects that are part of that namespace. So it will protect the deployment objects, the service objects, the persistent volume claims, and a secret that was part of my WordPress app. So I can come here, I can look at show details and click through like, okay, what's being protected. So persistent volumes, persistent volume claims, one secret where I'm storing my MySQL password, a couple of service objects. So right now it's talking to it, and you can monitor your backup operations from the same user interface itself. While this is happening, I can look at additional things like, okay, have I done any of the restores, and keep track of all the different restores that that have been performed in my PX backup environment. And I can look at any scheduled backups that I might have for this specific cluster. So for PX backup, we have a WordPress hourly. So every hour it basically takes a new backup for my WordPress site and stores it in my backup repository. If I come back, our WordPress on-demand backup has been completed. So let's do this. Let's go back to the CLI and just delete WordPress completely. So let me navigate to the correct folder where I have my YAML files, and then I'll do a kubectl delete -k because I want to use all the YAML files in this directory. And then I'll delete everything in the WordPress namespace. So we deleted secrets, services, deployments, persistent volumes. Again, all the different components that we just saw. Takes a while for the persistent volumes to get deleted. But yeah, now if I do a kubectl get pvc in the WordPress namespace, I'll see that I don't have any persistent volumes. If I do a get all in the WordPress namespace, I see that I don't have any deployments or service objects or pods running. So at this point, this is like we can use PX backup and perform a quick restore. So I can give my restore a name, choose a destination cluster. So again, I can restore it to the same cluster, or if I want to restore it to a different cluster that's managed by PX backup, I can do that as well. We want to restore it in the same cluster. From a namespace perspective as well, like if I don't want to replace it to the same WordPress namespace, I can create a new namespace and restore my application there as well. If I want to do a default restore, it will just deploy it back in the same WordPress namespace. If I had accidental deletion of persistent volumes, I can just choose to, instead of restoring everything, I can just choose to restore persistent volumes using PX backup itself. So it will just deploy those for me. Since we deleted everything, we'll basically go ahead and deploy all resources. And then you can, if you have certain objects that are already running, you can choose to replace them or keep them as is. We'll replace everything again. We know that there isn't anything that's running in that namespace. And we can, we need to give it a different name, demo. Okay, and then hit restore. So now the restore operation is in progress. We can navigate back to the CLI interface, kubectl get pods in the WordPress namespace, and I can put a watch on it. So again, it will go through the deployment of the persistent volumes, creation of the Kubernetes deployment objects, Kubernetes service objects, and then eventually spin up my application pods as well. So it goes from pending to container creating to eventually running state. So again, it will take a few seconds for the application to come online, and we can navigate back to it and make sure that all of our data that existed before we deleted and backed up the app, the WordPress site, is now running as well. So okay, so I have both of my pods running. Let's verify that all my service endpoints are back and see if my IP has changed. So this is the new load balancer IP. I have my pods that's running for the past 30 seconds. Let's navigate to the new UI. Okay, one second, like we'll have to wait for it to come online, like all the pods. Okay, just a second. And now our application is back online. We had created a couple of posts for this demo. So this is, since this is the August monthly demo, we had a post for it, and you can see that we have successfully restored it to its previous good, well-known state as well. So that's the second piece of the demo where we talk about data protection when it comes to VMware Tanzu. Let's use the time that we have remaining to talk about Synchronous Dr and how you can connect two different VMware Tanzu clusters and configure an RPO of 0 for your application. So again, disaster recovery and business continuity, everybody knows the need for it when dealing with traditional or VM-based applications. And we see articles every now and then about how many businesses are not completely able to recover from a failure or a disaster event if they don't have a robust DR strategy in place. So just because you're modernizing your applications to use containers, doesn't mean that you can let go of your DR plans. You need a solution that can help you build those disaster recovery plans and have a robust architecture that can sustain disaster events. So we'll log out of this backup cluster again, and then log into our the first of the site A of our Synchronous Dr relationship cluster. So let me again go ahead and fetch the command so I don't have to type it. So here, as you can see, we have a new cluster called the site A cluster that's running. Let me enter the password for our admin@vsphere.local account, and then we can use a kubectl config use context command. Here in this scenario, the two clusters are just named site A cluster and site B cluster. If I do a get nodes, I have one control plane and 3 workers that are running. This time I'm running Kubernetes version 1.20.2 just to mix things up. And then if I do a get pods in the kube system namespace, you'll see that we have Portworx running as well. One of the things that I want to highlight in sync dr configuration, let me find the command for it. And then select and specify the Portworx pod that's specific to this cluster. So we have nfpt v7, and we are logged into the node that's running our Portworx pod. If we do a opt pwx bin pxstore, and then if I do just a simple status command, I can see that even though my site A cluster just had 3 nodes, if I look at my Portworx cluster, which is in this case a stretched cluster across 2 VMware Tanzu clusters, has 6 nodes that are contributing storage. So it's just one single cluster with 6 different nodes. We have 1, 2, and 3 nodes that are from site A, and then we have 1, 2, and 3 nodes that are from site B cluster as well. Again, in this case, my Tanzu Kubernetes clusters are running inside the same data center, although they are running on different pieces of hardware, like different flash stack systems. They are still able to talk to each other. They are able to meet the latency requirements. So I can create that synchronous DR relationship between the two clusters. Now that you have seen like what Portworx, what it looks like from a Portworx perspective, where we have an aggregated capacity from 6 different nodes, let's go ahead and look at the cluster pair, if I can type it correctly. And then just to like make things look different, instead of demo namespace, you're using demo2. For this one, I can do a stork-ctl get cluster pair in the demo2 namespace, and I can see that scheduler is ready and storage status is not provided. Again, this is important because let me go ahead and show you the YAML file that I used for my sync dr cluster pair. So Tanzu demo. Okay, this is the cluster pair YAML file for our synchronous DR. The reason we don't have anything is because whenever I have deployed an application on a synchronous DR VMware Tanzu cluster, it will, whenever it writes anything on site A, Portworx handles the replication at the storage layer. So we don't need to rely on Pxdr to copy our data every time every time we hit a different schedule. Since this is sync, even before we act the write operation, our data is copied to the second site. So let's exit out of this YAML file. Let's look at the schedule policy, and we'll talk about why that's important in this case as well. So we have a demo schedule policy for every 1 minute interval. And again, you might think about like, okay, why is this 1 minute if this is supposed to be synchronous DR? This is not to copy the data, but any changes to the Kubernetes object. So if I might have scaled my deployment set, or if I might have created new service objects as part of my application, this schedule policy basically copies those Kubernetes objects over to the second site. Data is synchronously getting replicated to the second site. This is just the Kubernetes objects. And you can find additional, let's look at the migration schedule that we for this synchronous replication. So you can find additional details. So here it's using the demo2 namespace. It's using our cluster pair called Tanzu demo. It's copying all of our resources because we need to copy Kubernetes objects to ensure proper recovery. It's not starting applications because, again, similar to async dr, we don't want any inconsistent state when it comes to applications. Include volumes is false, again, because the replication is handled at the Portworx layer, Portworx store. Portworx storage or Pxstore layer, not the Pxdr layer. And then we are basically confining this migration schedule to the demo2 namespace, and it's using our demo schedule policy. So we can go ahead and apply that migration schedule and use kubectl get pods, sorry, not pods, but migration schedule in the demo2 namespace to look at more details, like, and then use storkctl get migration schedule in the demo2 namespace as well. So right now the replication has already started. It will the replication for data, we don't have any application running, but all the objects, it's monitoring my namespace for anything new that will be deployed and making sure it gets copied over to our secondary site or second site. So let's go ahead and deploy a new WordPress site. So if I do a cd WordPress, and again it's the same YAML file, so I'll go ahead and apply the entire directory in our demo2 namespace. And if I do a get all in the demo2 namespace, you will see that we have 2 pods, 2 services, 2 deployments. And then if we do a get pvc, we have a couple of persistent volumes that's using our Postgres storage class as well. Let's do the get all command again to get an endpoint for our front end site. We'll wait for the WordPress site to come online. But this is where once we are able to access the front end of the WordPress site, we can basically write any data and it gets copied over. I see that we have 4 minutes remaining. I'll keep going for a couple of minutes. Let's see where we get. If not, we can we have more resources available. We have previous monthly demos, future monthly demos that are planned around this topic. So again, you can reach back out to us and we can do a one-on-one maybe. I just wanted to cover all the different use cases in this demo. If we do a get all again, you see that our WordPress pod is now running. I can look at the external IP, navigate to it using our browser. And this is a new WordPress site that we have running. So let's just quickly give it a name, syncdr admin. And then create an entry and then quickly do the failover operation. So let's log in. Let's create a new post and then hit publish. So we have a new WordPress site with just 1 post created. Let's go back to the CLI and let's perform the actual failover operation. So let me get the command for it. So one of the things that I like, as I was looking through my notes, I forgot to show you was storkctl get cluster domains status command. So this shows that our local domain right now is site A. That's where we are logged into. And then my site B and site A are actually in sync. So anything that's written on site A is getting copied over to site B. We can run a storkctl deactivate command to break this relationship. Again, this is just me trying to simulate a disaster event. Activate. So if you run that command again, eventually this will go out of sync. But since we want to simulate the failure, we'll use the scale command and set the replicas as 0 for our deployment object. So for deployment WordPress in the demo2 namespace, and then we'll do the same for our deployment MySQL. So if we do the get, you can see that, okay, now my site A is not in sync. Site B is the one that holds my all my data which hasn't been interrupted. So let's log out of this and let's see if we can access all of our data there on the second site. So let me log into the second site. So we are now logging into our site B cluster. Again, if you do a get all in the demo namespace before activating anything, you will see that we have our service endpoints and deployment endpoints that are ready to go. I can just do a stork ctl activate command in the demo2 namespace, and it will increase my replica count. So if I do, once that's done, if we do a kubectl get all again, I'll see that pods are being created for me to bring my application online on the second side. So it's still in the container creating phase, but I feel that we are close to time. So Andy, do you want to switch to the final couple of slides? I can stop sharing. But as you can see, we have our application that's now online on the second side, and we can access it, and all our blog posts and like things will be available on the second site as well. So let me stop sharing, and I'll hand the baton back to you.
Thanks, Bhavin, and really great demo there. We have one question while I do this. So you talked about backup, about having different cloud backend targets. This question is, can one backup job be backed up to multiple target buckets? I know you touched on the multiple target buckets available, but can you expand on that a little bit while I pull this last slide up?
Yeah, so you'll have to create different backup jobs. You can use the same schedule, so your backup is triggered at the same point. But for each backup job, you can just select one backup endpoint. So you can have, let's say at 3 o'clock Eastern, you want the backup job to store back your data in an on-prem bucket, and in the cloud bucket, you need two backup jobs that use the same schedule policy but different backup repositories, and you can achieve that architecture.
Perfect. And I think that's it for questions. I know we're at the top of the hour. A few resources here just to touch on. I mentioned the free trial at the beginning. We also have a YouTube channel that has all of our monthly demos. You can sign up for next month's monthly demo at that ask.portworx.com. And please check us out on Twitter, on the blog. Bhavin has a number of great posts that are out there on the blog about Tanzu. So thanks a lot for joining us, and we hope to see you next month.